Alright, this is the test review for the upcoming test. Go ahead and watch over this once you've already tried or if you're stuck on a problem. Fast forward till you see me working on it. Let's begin. If I have 21 liters of a gas held at a pressure of 678 kilopascals and the temperature 900 Kelvin, what will the volume of the gas be if I decrease the pressure to 454 kilopascals and decrease the temperature to 750? So this is a combined gas laws question because it's asking for a change, right? We're noticing a change. So the combined gas law, and I suggest you guys write this down every single time. I mean, I might write this down at the top of the paper or at every problem. P1 V1 over T1 equals P2 V2 over T2. Our V1 is 21, our P1 is 678, and our T1 is 900. So I'm going to go ahead and write this like that. 678 times 21 all over 900. That's going to be equal to 454 times V over 750. Solving for the volume, we get so 678 times 21 divided by 900 times 750 divided by 454, 26.1 liters. Moving on. If I have 2.9 liters of a gas at a pressure of 5 atmospheres and a temperature of 50 degrees Celsius, what will the temperature of the gas if I decrease the volume to 2.4 liters and decrease the pressure to 3 atmospheres? Cool. All right. So we start off with 5 atmospheres. So I'm going to go ahead and write that down for my initial pressure. Volume is 2.9. Our temperature is 50 degrees Celsius. We need to get that into Kelvin. 273 plus 50. This is 323 degrees Kelvin. Degrees Kelvin. We want to know what will the new temperature be, so we just write 3 right there times 2.4. We want to find our temperature. 5 times 2.9 divided by 323 divided by... Alright, so I'm actually going to do some quick algebra here. I realized I was mid-problem that I need to do some. So to bring the t over, we're going to multiply the t over. It's going to be t times 5 times 2.9 over 323. It's equal to, and I'm just going to solve this out real quick, 3 times 2.4, 7.2. Now we just want to divide this whole quantity over, and we're going to get our right answer. So let's do 5 times 2.9 divided by 323. Okay, we get this. So 0.045. So now let's do 7.2 divided by 0.045. And we get our temperature in Kelvin to be 160 degrees Kelvin. If I have 17 grams of fluorine gas at a temperature of 17 degrees Celsius and a volume of 88.89 liters, what is the pressure of the gas? This is a ideal gas law because we're not looking at a change, we're looking at a snapshot, right? So it's nothing's changing here, we're just looking at a snapshot. So PV equals nRT. That's how it is right there. That's the ideal gas law, or PIVNERT, as we like to say in class. We have 17 grams of fluorine gas. So 17. We've got to find the moles of fluorine gas because we're looking for the moles. And let's look here. Fluorine gas. Fluorine gas. Well, fluorine, first of all, is one of the deadly 7, right? So if it's one of the deadly 7, that means it has to have 2. It always comes in pairs, so it's going to be F2. So the proper weight of F2 is actually 38. 1 over 38. Excuse me. 17 divided by 38. 0.45 moles. 0.45 moles. Okay? That's our N. Our T, 17, needs to go to Kelvin, so we need to change this to Kelvin. 17 plus 273, 73 equals 290. And then 88.9 liters. Okay, cool. We're looking in, this is important. Millimeters of mercury. That's important for our, what? Our gas constant. And for our pressure. All right, so let's set up this equation. So our pressure times our volume, which is 88.89, equals N, which is 0.45, times R, millimeters of mercury, 62.4, and RT, which is 290. .45 times 62.4 times 290 divided by 88.89. RP is equal to 91.6 millimeters of mercury. Very nice. Moving on. If I have an unknown quantity of gas at a pressure of 50 kilopascals, a volume of 25 liters, and a temperature of 300 K, how many moles of gas do I have? Cool. All right, let's have, this is another PV equals nRT question. PV equals nRT. Pressure is 50. Volume 25 equals how many moles? So we don't know that. N. R, it's in kilopascals. Our R, right there, 8.314. And our T is 300. So to find N, you do 8.314 times 300. Excuse me, let me do it this way. Let's do 50 times 25 and divide that by 8.314 times 300. 0.5 moles. Very good, very nice. I'm losing ink. Okay, I'm back with a new pen. How many liters of 4 molar solution can be made using 100 grams of lithium bromide? All right, so this question actually sounds very difficult, but it's not. We've already done this before. Let's go ahead and do this. Lithium bromide. Lithium bromide. Lithium right here. Oh, lithium's right there. And bromine is right there. So it's LiBr. So what's the proper weight of lithium bromide? Well, it's 7 plus 80. So it's 87. So if we have 100 grams of it, we're going to find out how many moles we have. So 100 divided by 87 means we have 1.15 moles of lithium bromide. So now how many liters of 4 molar solution can be made? Okay, so we kind of want to have to work backwards here. So remember, molar, or capital M, is just equal to moles per liter. Our capital M is equal to moles per liter. All right, we already know the moles and we want to get it to 4. So, okay, so we have 1.15 moles and we know that molarity is just moles over liters. And we want to know how many liters of 4 molarity solution we can make. So, if 4 moles per liter, right? And we know we only have 1.15 moles, so times 1 over 1.15 moles. Look at this. These moles cancel out, okay? So let's do 4 divided by 1.15, and we get 3.48 over liters, 1 over liters, right? Times 1 over liters. But we don't want that. We want to inverse it. We need to invert it. So we're just going to do 1 divided by 3.48, and we get our final answer of 0.29 liters. Now that's a very, very tricky question. I don't know if that's going to be on the test or not. It takes a lot of math to do that, but at least here you see how to do it and how it's done. And really, the trick is to use the units it gives you, right? Molarity is just moles per liter. So you can use this to your advantage, and that's how you figure out how to get that answer. Let's go to one that you're more likely to see. What is the concentration of 450 milliliter solution that contains 200 grams of iron chloride? 200 grams of iron 2 chloride, excuse me. So first things first, we got to find proper weight. So where's iron? There's iron right there. And there's chloride. So it's going to be 1 iron and 2 chloride because it's iron 2 chloride, right? So iron weighs 56 and chloride, Cl2, weighs 70. So we'll do 56 plus 70 gives us 126. So to find the moles, we're going to do 200 divided by 126. And that's equal to 1.59 moles. So we want to know the concentration of a 450 milliliter solution that contains 200 grams. So we know that 200 grams is 1.59 moles. So we can easily do 1.59 over 450 equals X over 1,000, right? Because this is milliliters. So 1.59 divided by 450 times 1,000. X is equal to 3.53 molar. Molar solution right there. All right. Last one on the front. How many grams of ammonium sulfate are needed to make 0.25 liters of a solution at a concentration of 6 molars? So how many grams? So let's work backwards here, right? Again, okay, so first let's find out how many moles of ammonium sulfate we need to make 0.25 liters, a 6 molar solution. So to do that, we have to just simply, it would be set up like this. It would be 6 divided by 0.25. 6 divided by 0.25. No, actually, it's going to be 6 times 0.25. That's right. Okay. Excuse me. So 6 times 0.25 gives us 1.5 moles, right? Because look at this. Remember, molarity is just equal to moles per per liter. So if we do moles per liter, and we multiply this by liters, this cancels out, and we're just left with moles. So now we have 1.5 moles. So now let's figure out the weight of this. Okay, so we need to know how much ammonium sulfate weighs. So the formula is NH42SO4. So that's the formula for ammonium sulfate, NH42SO4. So now let's calculate the total weight of this. I'm just going to do this off screen. So the weight of this is 132, or the proper weight, 132 grams. And if we have 1.5 moles, and we're given, and the proper weight is 132 grams, we're just going to do 132 times 1.5, and we get 198 grams. That is also a more difficult question. Let's look at this. Let me zoom out a little bit. Carbon dioxide phase diagram. Here we go. What is the phase of CO2 at 40 bara and negative 75 degrees Celsius? Here's 40 and here's negative 75. Right there, that is a solid phase. What's the phase of CO2 at 1 bara and negative 50? Let's see, 1 bara is right here. 50, that is a gaseous phase. What would a shift from number 8 to number 9 be called? That is called sublimation. Sublimation. All right, lastly, this is for the honors and the honors only. 230 milliliters of 0.4 NaF, or sodium fluoride, is diluted with 50 milliliters of water. What is the new concentration? Okay, so we need to find the proper weight of NaF. The proper weight of NaF is 42. So we're going to do 0.4 times 42. All right, and that's equal to 16.8. But that's 0.4 in 230 milliliters of water. So we're going to multiply this by the amount of liters it is. So multiply this by 0.23. And that is going to give us how many grams we used in the first place. 3.86 grams, right? That gives us how many grams of NaF we used to make a 4 molar solution in 230 milliliters. So now let's find how many moles this is. 3.86 divided by 42 is equal to, this divided by 42, 0.092 moles. And now let's just do 0.092 divided by 230 plus 50 divided by 0.28. And that gives us 0.33 molar solution. All right, any questions? Go back and rewatch. Hopefully this made sense. Good luck on the test.